Hi, yeah. So I'm Thomas Callahan. I'm on the board of the Cybersecurity Club here at UMass. I mainly try to organize talks such as this one. Today we have Oracle coming in with Fleming Christensen, who is a product manager at Oracle, who's going to talk more about Oracle, what they do, and how they do it. And then Matthew Carter, who's a director in specifically security, and he's going to talk a lot more of the cybersecurity related stuff in this whole talk. He has a whole slew of things that he plans on talking about, like IaaS, and a whole bunch of other really cool stuff. So I will hand it off to them.
All right, thank you, Thomas. I'm Fleming Christensen, and as Thomas said, Director of Product Management for SaaS Engineering. We used to be called Cloud Operations. We are the people who are responsible to deliver the SaaS services and make sure it's humming all the time. And we, of course, work with Matt over in the Cloud Infrastructure and Platform Organization on keeping things secure. Now, the history of this meeting was that we were actually supposed to come visit you guys on the Amherst campus back in March. That was just when the pandemic hit. And as we were preparing for our trip west out to Amherst from Boston, I was gonna bring around some Oracle tchotchkes to hand out. We can't really do that when we are now all remote via Zoom. So I thought I'd bring you something else. So take note here. If I can get the slides to switch, here you go. Go to oracle.com/cloud/free. And there you will find a bunch of free cloud services that you can try out anytime you want. You know about some of the exciting things coming from Oracle, including the autonomous database, and you can try all that out on the oracle.com/cloud/free. So that's my feeble attempt at handing something out while we are all remote. As Matt and I prepared for this, we realized just how much content Matt has and how well it fits your topic here in terms of cybersecurity. So we have decided to let Matt run with the majority of the agenda, and I'm going to let it switch over to Matt here. We can go further through my presentation, but I think Matt's material is much better for you.
Thank you, Fleming. How's everyone doing today? I'm hoping to get a lot of energy out of all of you late on a Friday to keep everything moving and upbeat. So if I prompt for input, I need a chorus of answers and really excited energy because we need it here on a snowy Friday in October. So appreciate that in advance. My name is Matt Carter. I do product management for our security products team. It's been a recent transition for me. I spent most of my career in the identity and access management area for more on-prem services. So I have to say this has been the most challenging job of my career, but also rewarding because as some of you probably, when you think about Oracle, cloud is not exactly the first thing that comes to mind, right? If I share this picture here, you're sitting on the mountainside, thinking about what Oracle does, and you're probably thinking a canister, right? They do database really well, but past that, I'm not so sure. So we're really in the underdog mode of trying to catch up with AWS and really play in the hyperscale cloud market. And we've had some validation of that. Zoom, with their massive business opportunity of COVID, ran out of capacity, and they needed to scale, and they found that the data egress cost on OCI was so much cheaper on it than it would be on AWS. I mean, we're talking like in the millions just on data transfer alone. So it was a good opportunity for us. I think Oracle Cloud, it provides some really cost-effective things. We're commoditizing, I think, infrastructure as a service in a lot of ways. So I think any business that's looking to expand their cloud presence, should give us a shake. We're not going to have all the features and functions of an AWS, but for the core stuff, there's a lot of good things there. I want to start off with a public service announcement. Many of you probably have the question, like the first question is like, where do I start, like with cloud and those sort of developments? And I understand from Fleming, some of you have had some internships and chances to go into industry and play with some things. But in terms of like, how do I get a career in cloud? The first thing I would tell you is like, look at cloud native, especially on the serverless compute side. Your Lambda services in Oracle, we call it functions, and the best place to start there is a reference architecture that one of our teams has built called MuShop, and I think it's a cute little play on the Greek letter, for microservices, mu, and then add in cute little kitties and a little e-commerce website. It's a nice little experience, and it's built from all of these cloud native technologies like functions and streaming, API gateways, and a lot of different code languages. So it's really easy to deploy. It's literally got an easy button on the GitHub site. You can just go in here. Once you've created your free Oracle Cloud account, you can just go and basically hit this button, and it'll throw that site up and all the tooling up onto your cloud infrastructure. So great way to get started in the serverless. I do believe that that's sort of the way of the future. It's sort of container modern, the next phase of containers is developing on serverless, and it's going to be a big jump for a lot of companies to make that change, but I think they'll find a lot of value in that. So transitioning, from serverless, like what are some of the things we think about when we're securing functions and lambdas? One of the things that I like to start with is like just validating the input coming into your service. And what I want to demonstrate real quick here is a quick example of securing a function and just basically putting some detection of a payload validation on that service. So we've got our API gateway here in a compartment. So just a little background here. Compartments are a way that we group resources within our cloud. So compute, storage, database, they all must live in a compartment. And this is one mechanism that we use for access control. And I'll show you a little bit of that later on. But essentially we've got for this MuShop deployment, I deployed an API gateway, and within that gateway, I've secured it, basically saying I need to have a token coming in, JOT token, which stands for, I forget what JOT stands for, but essentially we have an authorization service which will issue us that token, which we can use to make calls to this API gateway, which in turn calls a function behind the scenes. Just to show you some of the routing on that, we have our API gateway can front other HTTP endpoints, or it can put a function, in this case, function product info. And we can monitor it. So if we switch over to the monitoring service, we can see that we have definitions set up for alarming on certain things within that. So this, if we have an excessive number of authentications to that might be something we want to be aware of. If I click into that, we can see some of the criteria that we've set up here for defining when this alarm fires. So we basically say if the number of authentications fail with is greater than 10 in the duration of a minute, then we want that definition of fire, and we can send that through our notification service to an email. We can trigger another function, maybe to go blacklist that IP address where the authentications are coming from. There's a lot of different ways to structure that. The other one that I'm going to show you is essentially looking at the payload of that. So if the size of the payload exceeds a certain threshold, maybe they shouldn't be uploading large images to your to your function, that may be something that you want to block and alert on as well. So this is just some best practices around securing API endpoints in general, but we just happen to do it within a function context here. So just showing you the invocation of that service. So let me clear that real quick. First call I'm going to make is to our identity service. So you can find that. There we go. So we're making this to an OAuth token endpoint. And we've just got some credentials flagged in here, which I'm sure somebody recording that can go grab those credentials and hack my service, have fun. And we get back an access token from that. And now then we can use that access token, which is a very short-lived token. That's why I had to call the service again to get it. I can basically copy that token and add that into the header of subsequent requests. And this one's going to be a little bit slow just because the function's going to have a cold start here. So let me see if that's the right endpoint. No, let me grab that off my clipboard real quick. Bear with me. So this is calling the API gateway directly. Grab that access token again. Where's that end? I'm having trouble parsing that out. Well, you get the point. The idea is that we would get a notification that would look something like this. You can see from my email where I had those alerts sent to. If I pull that onto our share here, you can see some of the notifications that are coming in for excessive data transfers, and you can see some of the metadata around that notification. So just basic reactive controls around inputs to an API, just a best practice. All right, that's the end of my rather long public service announcement. Let me switch gears a little bit here. We're very proud of a recent release that we made in terms of cloud security posture. And I'm really excited to be talking to our budding cybersecurity experts here in this group because we've got a gap here, right? We don't have enough experts in this field, and we know that the number of applications and the number of settings is just scaling exponentially, and we just can't provide a manual solution to this. So we're going to have to automate some of this. So we basically took all of the various infrastructure services, and we plan to expand this to SaaS services, some of the things in Fleming's world as well, and essentially put assessment and detection around all of those services and various rules and prescriptive best practices around that, and provide visibility first and foremost. And we're calling this service CloudGuard. And essentially we want to detect those problems, provide some intelligence around that, provide some, regression to try to, determine, based on some of the user activity, whether these things are really problems or just noise, and potentially remediate. In some cases, customers may want to take a more aggressive posture around resolving those problems automatically. And I'll show you an example of that in the demo here in a minute. So the big chunks here that we think about is, what is the scope of what we're detecting? Do we want to detect just a subset, of our production environment and leave our dev a little bit more open and unmonitored, or do we want to monitor the whole tenancy? That's kind of the first decision a customer should make. Then it's a matter of, which rules do you want to detect, and are there any exceptions to those rules? So it may be your virtual network. You may want to look for certain ports being opened or not being opened. You may want to check for certificate expiration. You may want to check for buckets. That's the big one. Who here has heard of the Capital One breach, and can anybody like summarize what some of the findings were around root cause with Capital One? Come on, guys! Somebody's got. I need some high energy. Nobody here read about Capital One and like had.
Yeah, it was on Amazon. I would like to talk about it.
Yes, that's all you have to remember is it was not Oracle. It was Amazon. So essentially, a lot of customer records were essentially able. The attacker was able to move them into a public bucket due to an overly permissive access rule. I think on a web application firewall or some sort of proxy that had a role that essentially had too much access, and they were able to go through that intermediary to get to the data and move it somewhere where they could exfiltrate it. So these are the sort of things that we're looking to prevent. And a lot of these are reactive controls. Even with an active responder, you may not be able to prevent a malicious attacker, but most of the problems in enterprise, at least today, are accidental. And even a reactive control like this can head off a lot of problems early on. Even if it's an SLA, a service level agreement of an hour, you're probably going to be okay. So once we have problems, then for each of those problems, there may be separate activities that we perform. It might be disabling a user so that they can't perform, do any more damage within the environment. We may want to make a bucket private again if it's been set to public, or we may want to shut down some compute instance that is doing something that we don't find that is not sanctioned. Just to go through that sequence for that public bucket scenario, we have our configuration detector. Just a quick nuanced difference. We in CloudGuard, we're looking for not only configuration, like the state that an infrastructure service is in, we're also thinking about the transition, the change, which we call activity detectors. So we have combinations of both. And long term, we're also going to start taking in net flow. We're going to start taking in configuration from ERP and HCM applications. We're going to start taking in database activity. There's really no limit to the things that we can monitor here. And then once the problem is identified, we have essentially a person in the loop that could actively remediate that, or it could be triggered to or set to automate that to disable the bucket automatically. There's obviously access control ramifications here. The service has to be enabled to make that change on the customer's behalf. And as you might anticipate, customers get pretty leery about services making changes in environment. Config control is a big deal in a regulated environment, and you can't just go making changes willy-nilly. So we provide a little bit of friction there just to make sure that the customer is opting in to those changes. But once they do, if they do decide to automate, they can set that up, potentially emit that event to our event service where it can be triggered to the notifications of functions, just like you saw with the API gateway example of events and alarms triggering notifications as well. All right, let's jump back into our cloud service. If I browse to our security CloudGuard overview page, this is kind of our launching point for that operations view of what your cloud security posture is. What you see is a couple of different scorings. One of them is a relative scoring, sort of a normalized 0 to 100 evaluation based on all of the things, you know, relative to kind of more of a percentage basis, where the risk score there, 148, is more of a unbounded scoring, where if you have 10 resources versus 1 million resources, we wanted to be able to reflect that you may have 1 million problems with those 1 million resources, right? So it's sort of a that unbounded, you know, what is our exposure here? Within some of these portlets here, you see some summaries of problems that have already been identified in this environment that can be grouped by various perspectives from our different regions. We're mostly in the US East here in this particular tenant. You can see by type, most of our problems are user-based, but we also have some compute and networking, some policy, storage. So we've got a few problems across the board here, or that compartment resource grouping I talked about earlier. So let's browse into one of these, drill into critical findings within our test environment. And we see we've got several networking. VCN stands for Virtual Cloud Network. We have some ports that are allowed that are probably SSH ports for public compute instances that things are being flagged. And then we've got that public bucket, you know, very, very easy example, often used within the industry to talk about how, you know, what the risks are because of the Capital One and some of the visibility around that. So we can see that you can essentially ignore it. And that's one metric we kind of track to say, you know, are we producing useful reports, actionable type information, or are we basically producing noise that people have to go in and constantly, you know, say ignore this. So if we select remediate, we see the actual rule that basically says let's make this private. This is the access control statement I talked about. So we're granting the service the ability to manage, which is like you know, being able to make changes on object storage within this compartment. So if I click that, and that automatically provisions a policy, that's sort of the opt-in. The customer says, yes, I'm giving the service that ability. If I hit that remediate and acknowledge that, then it will start that process of pushing that change and setting that bucket back to private. So this is 2020-01, some random number there. Let's go into object storage and take a look, see how long that takes to resolve there. Yeah, there's our guy, and we can see that that's been set with visibility back to private. I talked about reactive controls, and obviously this is a detect and remediate scenario. Within Oracle Cloud, we've also introduced a more preventative measure. We call it maximum security zones, and the concept here is that we prevent these situations from even occurring in the first place. So we've got a bucket here in this e-commerce test data compartment, which happens to be a security zone. The boundary of a security zone is a compartment in our scenario. And if I try to set that to public in the first place, we prevent that from even happening. And we report it and provide all the alerting and alarming, but we prevent customers from accidentally or maliciously getting into that state in the first place. So that's a control that we have that can be a little bit more proactive in terms of preventing problems from occurring. So let me give you an idea, just going back to CloudGuard real quick. With CloudGuard, Oracle is the one that's defining a lot of the rules around what's considered a problem and what's not. So if we look at some of the recipes here, these are actually in the root compartment. You see there's a number of Oracle managed detectors. And if you sort these by various criticality, you see some of the ideas, some of the things that we're defining and the timing and the configuration. So 90 days for an API key. So this is us basically dictating what the rule is. customers also had the flexibility in our cloud, and this is critical for a lot of business scenarios, is the ability to make ad hoc rules around drift of configuration. And with a well-architected cloud like ours, we have consolidation where every service behaves the same. And one of those characteristics is emitting events to a single service where we can set rules around what we want to alert on. So in this event service, I've got a couple of rules defined here already. We have, this is named detect changes to password policy. So that's something that CloudGuard doesn't happen to cover, but we want, it's meaningful to the business, meaningful to the security team. What does that entail? So if we take a look at the rule that we've defined here, we've essentially set for the service, for the identity service, any changes to the password policy, reducing the complexity of the password, or changing the network in which users can authenticate to the cloud's console page. These are the sort of things we want to know that changes have been made, and we can further expand the characteristics of that, within a certain compartment or a very specific resource that we want to track. We can set those rules, and then we can define what action is taken out of that. In this case, we have an email subscription set up to send a note to Matt in this particular case. So let me just kind of create one from scratch just to give you a sense for how we define that. So you can see all the different services we have here. If we want to do something in our API gateway, somebody changes a deployment, creates a new deployment, we can see that we can send that to our streaming service, which is our Kafka-like cloud service. We can send it to our notifications, which can in turn send things to PagerDuty or to Slack, or we can write our own custom function to take a particular action and change something on our cloud. And then we can further, going back into our change password policy, we can do testing on this. So this nice little test tool gives us a template of the API call that's being made to make that particular change to the authentication policy. And we can tweak that to say what conditions result in this event being triggered. So we can see the sample as is actually does match the rule, because I wasn't very specific about it. And so that's a nice simulation validation of the rules that I write. So that's, if I made that change within the identity policy here, if I go into authentication settings and make a change to say, limit my password length, reducing my security posture, then that would trigger that event to be fired, and I would get an email on that. So just in summary, CloudGuard, reactive controls, react and potentially remediate certain settings based on Oracle defined configurations for configuration change, configuration drift, activities, very specific things that we're looking for. Supplement that with event driven policy that notifies for certain business or security settings that you care about, and then further restrict preventative measures where you have invariant type policies of never have public buckets. If you know your organization has that policy, then you can use those preventative measures like security zones in order to ever get that, for that particular security boundary, ever getting into that state. Let me pause there, because that's sort of the first big topic of our agenda tonight. Wanted to see questions, concerns on our security posture in general, config control, thoughts on Oracle's solution here. Our console's ugly, you don't like the shapes. I'm happy. I've heard most of it. I bet you guys can come up with some new ones.
Matt, we can put this in front of any endpoint?
The CloudGuard is not meant as a multi-purpose, multi-endpoint protection service today. It's only monitoring OCI infrastructure today.
Okay.
We don't have an extensibility platform where Fusion can go and define their own detector rules yet. That's a roadmap item. We want to expand our ecosystem. We want our partners to basically build their detectors for McAfee, detectors for SIEM, all of these great sources of security information. We want all of that flowing so that CloudGuard does become that centralized policy problem, actionable problem operations view for doing things within the Oracle ecosystem.
All right, other questions? Anyone?
Feedback, is this overwhelming? Go ahead, I stepped on someone there.
Yeah, no, I think it's really cool. I just have like a quick question. So last summer I did a lot of AWS, and I was just wondering, I learned that there was a ton of materials online in terms of learning that, because it's a very mainstream and they've kind of put together this whole sort of pathway to learning it. Does Oracle Cloud have a similar platform for learning everything there is to it, or is it more so you just kind of got to poke around and experiment yourself?
Great question. So there are several education paths within Oracle. There are Oracle Cloud specific practitioner certifications that you can achieve similar to Amazon. We do not have a security practitioner certification yet. That's a work in progress. It's going to be focused around many of the controls that you see tonight, such as cloud security posture, identity management, access control policies, a little bit of some of the infrastructure as a service, and a collection of other things that there needs to be familiarity in those areas where there's expected to be proficiency hands-on within the Oracle Cloud, hyperscale cloud security solutions themselves. So I think a starting point for that education, let me see, Oracle Cloud, Oracle Education, education.oracle.com might be a good place to start. Everybody learns differently. I like to go and provision myself an environment and just start reading the docs and deploying samples, and that's why I recommended the Moose Shop, because that's how I learned. But certainly some of the more formalized self-paced learning and even in classroom learning are good options as well.
All right, thank you. That's good.
And the website just flashed guided learning up there. That's actually an acquisition we had recently, Iridice, right? Where it's learning in context. So as you work with the product, it offers you snippets of education for just the things that are available in the screen you're looking at. So that's yet another way of learning.
Excellent point. I think there might be exam discounts going on right now, if I'm not mistaken, around getting certifications. Like, I think a lot of this is basically free, if I'm not mistaken, for taking the test itself. So I don't know if that's necessarily COVID or just Oracle trying to differentiate cost-wise, but there's I think there are some good offers in the market right now. I think with the Amazon learning, at least with security, I know there's within their learning path, they have a lot of foundational stuff as well. So anything with security is in isolation doesn't really make sense, right? You're always securing something. You're securing infrastructure, you're securing a database, securing functions. So having that foundational familiarity with the cloud that you're trying to protect, having some good awareness of the peripheral adjacent areas, like identity, single sign-on. Those are things that you almost have. I recommend expanding beyond just that core area because security is always going to touch a bunch of things. So get that foundation, I guess, is my suggestion before going full in on security.
Thank you. I think we're good to go on to the next topic.
Awesome. Let me drag my PowerPoint back up here just to set the stage here. So part 2 of what I was going to talk about tonight was more around web application security. Have anybody here worked with like any of the open source web application firewalls or other commercial firewalls, or done any sort of OWASP investigation?
I mean, I've used OAuth for certain projects, but that's about the extent.
Was that OAuth you said?
Yeah.
Okay. Yeah, I actually said OWASP. It's a, I know that sounds
Gotcha.
very similar. OWASP is an organization that defines a lot of vulnerabilities, and they're famous for their top 10 areas of security risk oftentimes, which are typically things like SQL injection and cross-site scripting and weak APIs and weak access control and things like that. So excellent organization to get involved in, in your spare time if you're interested in like user groups and stuff. They tend to put out really good training content, and in the web application firewall specifically, they put out what they call a core rule set, which is a big basis for what we use for our own web application firewall at Oracle. So we have this service, and there's a couple of different form factors that you'll see with web application firewalls. There's really 3. There's a RAS, what they call RAS, which I don't remember what that stands for, but essentially it's a programmatic WAF where you're essentially coding in the application this sort of capability. There's also an appliance form factor. You'll see where you take like a virtual appliance and you deploy it on your VMware clusters or in EC2, and essentially you're responsible for configuring all the hardware and the networking and the high availability. But what Oracle has done is built really a cloud WAF, which essentially I like to think of it as a single instance of a WAF scaled like across many regions with over 100 nodes in every region, and you're not creating a WAF for your application, rather you're onboarding your application to this single logical WAF. And to get a sense of how we do that at scale, the benefits of that is that Oracle is dealing with all of the high availability and the scaling and the hardware. You don't have to worry about any of that. All you have to do to get onto our WAF is essentially have a domain, a web domain, that you have control over DNS. And you essentially tweak your DNS to create a CNAME for, or change the CNAME for your application to point to our WAF, and the WAF will essentially act as a proxy or reverse proxy to your application endpoint. And then you can apply all the rules to it and get all the benefits from it. So that's kind of our one of the things, if you're looking at WAFs, in helping your company someday evaluate WAFs, that's a key sort of differentiator in terms of form factor. The cloud WAFs tend to be easier to get on board, but it's still a little bit newer in terms of form factor. They haven't quite caught up, so a lot of the appliance vendors are still a little bit more ahead in terms of functionality. But anyway, so the WAF essentially provides a number of different rule types and capabilities. You guys are probably aware of some of the different automated bots that are out on the internet. Basically some scraping for information, that they can use, grabbing your intellectual property and reusing it, diminishing your own, value. A lot of them are DDoSing customers, both at, layers 3, 4, and layer 7. The WAF can help with the layer 7 DDoS type attacks. Some of those aren't just volume; they may be low and slow, or very specific probing type scenarios. And there's various business cases that can often be satisfied with a WAF. Limiting a particular geo. Say you don't want traffic coming in from outside of the U.S. and Canada. Very easy to use the WAF to use geo IP-based rules. Some of the techniques that we use for preventing some of this bot traffic is, looking for usage patterns around how they interact with the site. Machines tend to leverage very automated type patterns, and we look for that sort of I guess abnormal patterns to identify humans versus people, and we can essentially challenge with a CAPTCHA, to provide a soft challenge to allow actual humans, if they do get a false positive, to still continue to interact with the site, and then we can do some device fingerprinting as well. So I don't know if any of you have heard of Selenium in your schooling. It's a tool that's often used for testing websites, and a lot of hackers have taken that, and a common sales criteria is, they basically say, I'm going to automate a bot, using Selenium to access the website. And, vendors will say, hey, look, I blocked your Selenium client. The problem with that is that most hackers will take that source code and spawn their own, Selenium fingerprint and bypass those controls pretty easily. So this is a constant evolving challenge of trying to keep up with those attacks, and looking at it from the global standpoint, because most of the time they're going to replicate that bot, that Selenium bot, to multiple geos and multiple sources. So seeing that same fingerprint coming in simultaneously from different sources might be a clue that something's amiss. Just to give you an idea, when you're talking with cloud service providers, there's always going to be this shared responsibility model. This is something that is very important from a security standpoint, so that everybody understands who's responsible for what. So in the terms in the land of WAF, we try to make it easy, but it's still the customer's responsibility to onboard their application to the WAF. We basically provide a self-service. We're not going to white glove it. But where we do help is we're providing a set of rules that customers essentially just have to turn on in order to protect themselves against SQL injection, cross-site scripting, and common internet attacks. We're keeping things patched and up to date. We're monitoring for DDoS attacks, mainly to protect ourselves, to make sure the WAF stays up, but the customer does receive some benefits from doing that. And in some cases, we actually have a policy here at Oracle that if customers are being DDoSed over layer 7 and they incur extra cost due to like auto scaling from a DDoS, we'll help mitigate that, through some of these bot challenges. We'll get an analyst on the phone with the customer, help to puts rules in place, like rate limiting rules and bot rules, to help mitigate that DDoS attack. And we'll actually reimburse the customer for any costs that they incur as a result of overusage of those resources. This is just a quick example of some of the use cases where we can use statistical analysis to identify combinatorial header values to help identify what's good traffic and bad traffic. So we really haven't done a good job of productizing this, a true machine learning, even supervised machine learning solution, but this is something that we're striving towards and continuing to mature. And this is where the industry is going, because of that gap of trained SOC operators is so great. The vendors are being forced to really automate this and help the customers identify this stuff automatically. So let's see this in action. if you go to the OWASP website, you'll see a sample application that they call NodeGoat. And it has this nice retirement facade on it. And it's nice because it has some really nice examples of poorly written application code. If you can see here, I've got this query here that represents a SQL injection attack. I'm essentially tricking the database into returning asset allocations for more than just the user that's logged in. Obviously a no-no for us, right? We've got some really interesting names here. Zap Zap. I don't know what that is. So this is the sort of behavior we want to prevent. And obviously you could fix your application, and companies are getting better around incorporating this sort of rigor, or in the CI/CD process and the development process, to make sure these problems don't happen. But sometimes it takes a little while to get those patches into place, and sometimes it's in the platform, sometimes it's in the code. So a lot of times the WAF becomes a nice extra layer of assurance that we can prevent this from happening. So if you'll see this domain, insecure.burlingtonsolutionhub.com. So this is our insecure website. And what I did was I essentially took that domain and put our WAF in front of it. So we've got this new domain that I happen to control, and that's going through our WAF. And so if we try that same allocation SQL injection attack on this application, we're blocked by the WAF. You see some information, and this is more for the consumer. If they're getting a false positive, they can go report that to the company. I'm like, hey, I should be going through this. This is a valid attack. And then we can look up this incident ID in our logs and figure out what's going on. Another example is, and this is again, application coding can, always deal with these sort of things, but we've got a form here which is soliciting for input for what percentage people want to contribute to their retirement savings, and obviously we want a numeric value there. But if we put something in other than a numeric, again, that's something. That was not a good example. I'm back in the insecure applications. I thought I forgot I had skipped over. So if I go back into the WAF protected one for contributions and try to put in some invalid input, we could head that off at the WAF site. So I'll show you. I use this example because this is where I extended the rule set that Oracle provides with something that the customer can define for themselves. So if I go back into my console here and go into Web Application Firewall, and I am in the wrong tenant. Let me go grab the right one. Sorry about that. There we go. I'll grab the password for that one. And this is in WAF Retirement app. All right, here we go. So we can see we've got a number of entities that we can manage within our WAF. We have certificates because obviously the WAF as the reverse proxy needs to negotiate the TLS handshake with the actual browser. So customers need to have their certificates on the WAF itself. So we provide a chance to manage that. We saw that specific form validation rule. So this is an example of how we defined the inputs that were allowed for this particular URL, this particular form. Now this uses a language called mod security. And this is, I think, one area where there's a massive deficiency in our employment workforce. Like, I literally cannot find people that know this stuff as a hiring manager. So something that if you can put on your resume, I think there's a fair amount of demand for this. Check it out. And you can apply this in the open source WAF mod. Mod security is also the name of the open source WAF itself. So you can test this out for free in your own environments very easily. So this is the extending the WAF for custom rules, but we try to make it easy and define a number of rules out of the box. So if I go into the actual policy itself, we can see the domain that we're protecting. This is essentially one of two things that I had to enter in to get this domain running. Essentially define the domain and the proxy endpoint to where I'm sending the traffic. So here is the list of the hundreds of rules that we provide out of the box. I'm just going to filter on some of the things that we're blocking on, so you can see some of the rules that are actually enforced right now. You see some of the cross-site scripting, limiting the number of arguments, the length of the arguments, total length values. Maybe if we have a social website, we want to filter profanity. Pretty valid in today's political environment. And you can see where I've assigned that form validation rule here as well and set that to block as well. We provide a recommendation engine. You won't see any because I created this fairly, oh no, actually it did. So we look at traffic after a certain amount of traffic flows through the WAF. We'll start making suggestions on which rules are best applicable for that application. And furthermore, start defining some of the things around, which HTTP methods are allowed, whether or not we're inspecting the response. This is a nice little feature for ensuring certain data prevention. If you've got, a low traffic but sensitive traffic, because this is a very expensive operation, you may want to be looking for things like PII leaving over an HTTP transport or credit cards or things like that to make sure that data is not leaving your organization through the gateway. We combine that with a user-defined access control system, so we can define rules based on various criteria. I mentioned some of the GeoIP, so what country you may want to prevent traffic from or only limit it to, URL criteria, regular expressions for URLs, matching that up, IP lists, headers, user agent. These are the sort of criteria that security architects like to use for making sure that the right traffic comes through. And it's often a progression. We often start with detection only, which allows the request through, but we want to look at it through the logging. That's what our SaaS partners are doing. They're kind of at that stage right now. And once you have high confidence that the rule is not triggering a lot of false positives, then you can set it to block and really lock it down. Our WAF, because it's on the edge, can act as a CDN in a way. Like, you can essentially cache static content at the edge so that your application endpoint doesn't have to be serving your images all the time. So very cost efficient way to do that. We provide some logging capability out of the console, so you can see some of the metadata that we're capturing around a certain block. Here's our particular, our custom form validation. You can see the rule that fired and a rich set of metadata around the headers and which rule fired. And this is what we use for figuring out what we need to fine tune in case of a false positive. If we do get a false positive, we might go into a rule and say, hey, we're getting a block on this where we shouldn't. Maybe we want to write an exclusion, which basically you might say, if for this particular header or query parameter, we want to say just ignore this even if you see this rule triggered for that parameter. All right. That's what I prepared for Web Application Firewall. What do you guys think? Is this something that's useful, interesting, compelling?
Don't be timid.
I think it's really cool. I didn't really have much experience with it last summer when I did a bunch of cloud stuff, and now like knowing like what was actually probably done by the security people at the company is really cool. You also have some people in chat responding.
Let me take a minute to take a look at the chats. All right.
So Thomas has the question similar to what I was thinking here. He's asking with the policy-based stuff, how good is the detection for VPNs, right? So you were showing an example before, you were trying to block Afghanistan.
Mm-hmm.
If you sit in Afghanistan and you VPN into a proxy server in Germany and then connect over the internet from there to Oracle, you can't tell that that's coming from Afghanistan. Is that correct?
Correct. We would not be able to thwart that. However, we do have a feed from a partner called WebRoot that does have and maintains a list of Tor nodes. So we can prevent Tor node traffic to say, you know, based on what WebRoot gives us. So we essentially just turn that on, and if you try to use the Tor network, you know, and that's very easy to test with just a Tor browser. You can see that traffic getting blocked. So some controls, but not everything.
Right. So this is actually an area where I am a customer of Matt, right? So Matt in the infrastructure team is preparing a security offering like this. What we're doing over in the software as a service arena is taking that firewall and wrapping it around our SaaS offerings to make them more secure, right? But that means we become the customer and we take responsibility for what was in that column when Matt showed the distribution of responsibilities between Oracle and customer. Then Matt is Oracle, but I'm the customer. And whenever you get to the software as a service level offering, we consider that kind of red velvet glove service, right? And we do everything for the customer. We become the customer. So we configure Matt's firewall in front of our SaaS offerings.
Our SaaS partners are, awesome in terms of, giving us good feedback, but it's like family. Like you're very frank and honest with them because they are partner organizations, and so it's colorful oftentimes, the interactions.
Matt, there's a couple more in the chat here. How does Roth compare to a service like Cloudflare?
Yeah, Cloudflare does a really nice job of keeping costs really low for, combined DNS and WAF and CDN. I think that Cloudflare is an excellent choice for a lot of websites. I don't have any issue with them. If I were to nitpick, it would just be some of the negative publicity they've got around not really taking a position on hosting maybe less than savory type websites. So there might be some noisy neighbor sort of concerns there, but I think that's probably, I suspect they probably do a pretty good job of keeping that negligible. So Cloudflare is a great choice for standard websites. No issues there. Does Oracle have a bug bounty? Not that I'm aware of. I would love to see that, like, honestly, like getting, all of you hackathon experts are probably aware of things that I can't even dream of. And I don't have a good answer for that. I don't think we do, and it probably should. So maybe Fleming, if you could, remind me on Monday. Let's see if we can't get something going and see. I don't know if there's any policy that you're aware from the security assurance folks against that.
No, I don't think so. I mean, we offer service credits if we don't live up to our SLA. Of course, we do live up to our SLA, but in case we don't. customers get a service credit.
Yeah, it would be money well spent, in my opinion. Like you find
service credits are silly because what a customer wants is not money back, right? What they want is a reliable service. But I love the idea of the buck bounty program, and I'll put that straight in AMA Steve, which is our internal Ask Me Anything for the big boss, and we could bring it up there. Absolutely.
Yeah, and with the free tier stuff, I mean, it sometimes becomes a challenge just because we have our, there's a certain teams that are looking to protect the cloud itself. For example, DDoS, we have devices called arbors, which is kind of the go-to for filtering DDoS traffic in every region. So these guys are always monitoring that sort of layer 3-4 sort of DDoS protection behind the scenes, and they'll go and black hole IPs and stuff. So you have to be careful around. It's good to kind of get on the sanctioned list if you're white hat hacking for on Oracle's behalf. So don't go off and start doing something and expect to pay out after the fact. Make sure you're on the good list before you go do that. But
right.
We'll see if we can figure it out.
All right. Any last questions on the application firewall? If not, I think you had a third topic, right, Matt?
Yeah. I want to spend some time around access control, and this is I might get a little bit preachy on this one. This is kind of where I grew up and have a lot of strong positions here. I wanted to pull up this page here. Let me make it a little bit bigger. And I want you guys to take a look at this scenario here and some of these natural language statements, and just think about how you might model access control for this scenario using like a traditional role-based access control policy model, and see if you can kind of think about like what are some of the constraints there. While you do that, I'm just going to take a quick break. So read that and reflect for a minute. All right. Any reflections on this particular exercise? I can send this URL if anybody's interested. what do you think some of the limitations are modeling an exercise like this in RBAC, role-based access control? My take on this is that, you know, as an industry, we've gotten into a bit of a lazy habit, right? RBAC conceptually lumps together permissions and says, you know, an operator can view these things and perform these actions, and an administrator can do this and this, and you know, and we basically give access by putting users into those groups. And that's very easy for us to get our heads around conceptually. The problem is these days with cloud and IoT and, you know, Internet of Things, the number of resources and the number of permissions and operations are just, you know, blowing up. The number of types of users are also expanding. I've my history, and I didn't really introduce myself, you know, from a history standpoint. I mentioned that I worked in IAM, but I've done that in a pre-sales and also a delivery and you know, kind of a billable sort of professional services role as well. And I've been in some banks that have thousands upon thousands of roles, and they lose control. They cannot attest to who has access to what, and that's a big deal for them from a compliance standpoint. And this role explosion that occurs is a byproduct of the way we've conditioned ourselves to control who has access to what. So I put this example together 8 years ago, and really I've been in a couple of companies where we were trying to sell an alternative to that, to RBAC, which was more contextual or attribute-based access control, where essentially you're comparing some label or tag or attribute of the resource that is being requested with some attribute of the user. In CISSP terms, that's one of the certifications in our industry, they call this mandatory access control, which is a terrible name, and another reason why this stuff, you know, isn't getting adoption. But the idea is, you know, I think the promise of it is it reduces the policies in the role management. You essentially are pushing the responsibility of access control to more of a discretionary model of the content owner. So by labeling a particular object storage with a particular tag, for instance, you can essentially give access through the label of, you know, on the resource itself, and then the policies become rather static. So if you think in a, you know, Department of Defense, very easy example, the user can access content if their clearance is greater than the classification of the resource they're trying to access. That single policy could govern just about anything in DoD if you had a well-structured attribute metadata environment, in theory, right? And the real world's messy, and it doesn't always work out that way. But I think as young cybersecurity engineers, like, I love to advocate for this, and I think the promise of you know, risk-based and context-based models is really essential to us moving forward as an industry, because this RBAC problem is just constantly weighing us down. How does that manifest itself? What has Oracle done about that? So let's go back into our cloud world. So in our governance section, we've provided the ability to define tags, and this is critical for keeping track of cost. That's the primary use for a lot of this. So we've got some tags here in our demo, which one is a cost tracking tag called Cost Center. So, you know, users, when they create a resource, they can say, this is, you know, my cost center is 1, 2, or 3, and then they can essentially allocate for chargeback reasons, who is, which cost center is using which resources, and that's very important to customers. It can also be used for access control. That's really the more important, relevant thing to what we're talking about here. So if we use these what we call user-defined tags, we can essentially say, you can define something as prod, test, or dev, and then you can govern your access control policies based on these tags to say, you can access things in this compartment if the tag is set to, test or dev. And we're not always talking about users. Sometimes we're talking about machines. So oftentimes we have a service or something running on a compute instance that we want to govern access control for. Well, we always want to govern it, but sometimes we need to define. In Oracle, everything's a deny until you actually explicitly grant access. So that's a concept called least privilege that you'll hear often in the industry. So essentially, the way we modeled it is something called a dynamic group, which basically defines which compute instances can perform operations on other services. And this is an example of a tag-based policy where I essentially say any compute instance that is tagged with this compute admins DG tag name in the operations namespace, irregardless of value, is assigned to this group. They're dynamically allocated this grouping. And what I can use that in turn is assigning a policy based on this dynamic group. So if I browse to staying within our identity and go to policies, we can see that in our storage policy, we have a number of traditional role or group-based access control policies, allow group storage admin roles to do things, but we've also defined a dynamic group policy to say compute instances that have that particular tag can now perform database operations within this group. So in this case, we don't have to define each individual application tier to database tier access control list or an ACL. You don't have to do those individually. All you have to do is assign the tag to the compute instance and they can perform that database operation. So this is a way to limit the exposure from a security standpoint while maintaining a manageability level that is reasonable for administrators to keep track of. There's a lot, I said a lot there. Let me kind of pause there and say, do those concepts make sense? Any dissenting voices on my context-based position there?
I think it makes sense. I can see somebody is saying the same thing in the chat channel.
Thank you, Thomas. Thomas is concerned, validating.
Yeah, I recently deployed an instance of a service to a new environment. Just to give an example, this is a SaaS level service, but I think we had about 90 different entitlements and we needed 2 parallel sets of them. So just for one offering, we created another 180 entitlements. So you can imagine that how, with many different service offerings, we're talking thousands and thousands of these roles.
And you know what all of them mean, right, Fleming, by name? I'm being facetious. Like, yeah, they tend to be very cryptic names. You'll have like foo _bar _ blah blah blah, and nobody knows what they mean. So they just end up just well, I'm sure that won't do any harm. And
yeah, I mean, they're typically tied to roles, right? So a customer support engineer who's on the phone with a customer may need to be able to retrieve a log slice to look into an issue, but he may not need access to the database itself. somebody else in a different role has different needs, and I guess that's obvious, but that's how we end up with the number so high. So that certainly resonates. That is exactly what we're dealing with.
Yeah, it's a big challenge in the industry. We tried to simplify it in Oracle Cloud. We tried to provide this, some templates to make, these common activities pretty obvious, and provide. I'd say our natural language model is sort of a mix between RBAC and ABAC. As stated here, you've got essentially an effect, allow, and we only have the allow effect because everything is deny unless you grant an allow statement. So we don't introduce denies to to have to adjudicate between the two. Which keeps things simple, I think. Allow a group or a dynamic group to manage, which is sort of our meta verb. Essentially have read only, manage, list, a couple different levels, and then every resource in the cloud has its own family and sub resource components that you can define policy on. And you can further constrain that with a condition. So you can essentially say where tag equals prod. And so that's where the hybrid role-based and group-based comes in. This was done before I came in, so I didn't get to advocate for a pure ABAC attribute-based model, unfortunately. But we're still fighting the fight and trying to influence to simplify this. And personally, I'd just rather see put a user in a compartment setting and give them access to a compartment. Something very simple like that to really streamline the access control policy. Couple of other features I wanted to highlight from a security, just selfishly wanting to tout some of our services. Has anyone here used HashiCorp Vault? Are you familiar with the concept of a secrets management service? The idea with a secrets management service is that you can essentially store. Let me actually switch to the other tenant here because I've got a really quick example. You can store secrets like passwords or OAuth credentials, whatever service to service, machine to machine type credentials. You don't want that in your code. You don't want that in your config if you can avoid it, right? So we basically will store those for you, encrypted at rest and on the go. Let me see, where did I put that vault? I think it would have been here. There we go. And then the calling service, think of it as like the application tier and a classic 3-tier example. The application tier can call the secret service to get the database credential on an as-needed basis, where it's not stored on the application tier itself. It can pull the secret at authentication time to create that connection to the database. And we can version that. And where the pattern that I think is meaningful is being able to rotate the password of the database on a regular basis without ever having to give that database credential out. You don't have to push it out because the application tier is picking up automatically. So I've got this script that I wrote that essentially rotates the password on the database. Let me make that bigger. Wrong direction. Give you guys a quick look at it. So this CLI just creates a random password, and the first thing it does is it updates the secret in the secrets management service. This is just the unique identifier for that secret, and then it rotates the password on the database itself. and the application calls the service to retrieve the secret, you never see the new password that's generated. It's never out in the open. So I can just show that in real time here. You can see behind me, we're on version 4 of the secret password. If I run that script, we should see that rev to number 5, hopefully, and the password is updated on the database. And when I show that, and I apologize, there it goes, rev to number 5, you see it go into updating state. CLI, very easy to use. But you know, I lost my demo environment, unfortunately, where I have the application, you know, calling the database, and you see the application continuing to work, but you try to log into the database through like a SQL developer tool, and the connection is lost and you can't get into it with the old password if you somehow came into it. And you could hypothetically rotate this every hour, every minute, you know, as much as your secret service will allow you to use it. You can keep that password rotating on a regular basis, which increases your security posture, in my opinion. So just an interesting pattern that we use for secrets. I mentioned HashiCorp Vault. They've got a nice enterprise level solution, more of an on-prem. We like our cloud shape, you know, for all the goodness that cloud brings to it, and the price is right. It's basically free. So you know, if you've got secrets you want to maintain, have fun with it. We also use an HSM-based key store. So really, a key encryption key is what we can generate and keep that inside the HSM. HSM stands for Hardware Security Module. And then those keys can essentially, how did I get over here? Pardon my navigation, I'm tired. All right, back in the vault, we got our encryption keys. You can create keys and rotate them, and these are used to store, or sorry, encrypt the data encryption keys that are used for object storage, file storage, block volume. So very easy to keep your data encrypted on the cloud using keys that you control the life cycle for. You know, very easy just to hit rotate. When you do rotate them, we keep track of the versioning, so we can actually decrypt using an older key version, so you don't have to worry about rotating your data encryption keys every time. And on the object storage side, it's very, very straightforward to select those encryption keys and use those on your actual data. Do that real quick here. We've already got one assigned, but you essentially just select the encryption key that you're using to encrypt that data. So we try to make it really easy. 20 key versions per month we give away. So there's a very generous free tier here. You know, no charges on the data plane. So, you know, if any of you guys are looking to provide like a managed cloud service, you know, I think there's some interesting opportunities from a cost standpoint of reselling some of this. Probably shouldn't be saying that, but there's some interesting, I think, business opportunities around this stuff if you can you know, become an expert in it and you know, take advantage of some of the nice cost opportunities for some of these things. And that's the key stuff I wanted to highlight and all the things I prepared for tonight. You guys have been a wonderful audience. I will open it up for any question, like, you know, how do I learn more? How do I, you know, become a product manager? I don't know why you'd ever want to, but no, I'm kidding. It's a challenging and sometimes rewarding job. So thank you. And any questions?
Open broadly, anyone?
Looks like there's a tile for free training out of Oracle University out of the console. So maybe, you know, spinning up a free tier and, you know, going through some of these links might be a nice way to get started.
Right. I think it's very good to hear from the OCI security team and from Matt here, but I hope you also see it as a wider theme around Oracle, if you wish, has become security and performance you usually don't hear it in terms of performance. What you hear it in terms of is price per unit, right? So, but that's the same story. One of the proud achievements that our founder likes to talk a lot about is the autonomous database. That self-healing, self-patching database, and in essence, that project started with the realization that more than half the cost of operating a database is the database administrator. And so the automation effort really started by trying to take out cost. But in reality, I think we realized that there was a much bigger advantage from a security standpoint because of the fact that you are patched so very, very quickly. The vast majority of the vulnerability exploits we see happening across the industry are happening with exploits or vulnerabilities, for which the fix was already available but had not been deployed to those machines yet, right? That's a very common thing across the industry. I'm not talking about Oracle, I'm talking about everybody. And so it simply takes too long across the industry. It can take 6 months, it can take 8-10 months for a full rotation of rolling out patches across a large enterprise. We see that. And so with the autonomous database that we offer, you're patched, almost the same day, basically the same day that the fix comes out. And that closes a large security problem window.
Yeah, and at the Linux level as well, I'm showing some of the operating system management, for some of the auto patching using Ksplice and really trying to reduce the friction around getting patches applied, especially security updates and keeping track of that.
So security and performance, I think, are themes, are strong suits, whatever you want to call it.
Zero downtime, they advertise for some of the Linux patches, which I think is pretty cool.
Yes,
I think interesting, computer science going on with that. Finding like the low, kernel activity periods where they can perform those things. Some really interesting science there.
There's a question on the tags. The idea of switching from the many roles. Won't you see that problem result in equivalently, many tags?
Yeah, great question. I think that if I talk about putting the onus of tagging on the resource owner, a lot of that I think you can factor into your CI/CD process through automation to make sure the appropriate tags are applied during the deployment process. So Thomas, you're absolutely right. If you're expecting people to go and manage those tags manually, you're going to end up in the same place. So if you can't automate that tag assignment process, then it's no better. I would agree.
Okay, we've delved into a couple of particular security arenas here, or domains, but anything else? We'll open it up for any question on your mind. It is Friday night, but if you have one more.
If we had pizza and beer, we'd probably have a lot more lively discussion. Yeah. Yeah, I hope you guys get perspectives from Amazon and Google, some of the other cloud providers. They're all great offerings. They all have their pros and cons. Google has some great machine learning tech. I think Azure's doing a great job building composite services, and they've done a nice job with Security Center. So get as many perspectives as you can. Figure out what the right cloud is for the right workload. And each is going to have its own strengths, and we hope to be, I think we're a niche player today, and hopefully we can, be one of the major players tomorrow. And I think that's where all the I wouldn't want to be a pure play security vendor in this space anymore, because I think the cloud providers are going to, because they have all the scale already built into their systems and services. They solve for the hard stuff early, and it's they just have to build the functionality, and that doesn't take so long these days. So if you're considering a career in the industry, I highly recommend the cloud providers as employment sources.
All right, back to the moderators.
I got it. Yeah. Yeah, no, I think we'll wrap it up there then. Thank you guys so much for your time. That was extremely informative. I learned a ton. I hope everyone else also learned a ton. Thank you to Fleming and Matt for coming out, especially on a Friday night right before Halloween. And thank you for everyone else coming out at the same time. I know it's midterm season and it's a hard time for everyone to spend this much time on anything but school. So thank you all for coming. Thank you so much for talking. I hope you guys can come talk again sometime.
Would love to come back.
Hopefully
All
on
right.
site someday on campus.
That'd be even better. I think we all hope we're on campus pretty soon. So yeah, on that note, we will end it. Thank you again.
Everybody be safe. Very nice
Everybody.
talking to you.